Namaskar, welcome back. So, last lecture we were discussing about the wave height and wavelength and how it will reduce when it approaches the coast and how it will be in the deep ocean part. Okay. So, as I told that this part we should keep in mind that as the waves approaches tidal waves, it approaches the coast due to friction, it will slow down, the wavelength decreases and the height increases. Okay. So, this process also is applicable to the tsunami waves. Okay. And tsunami waves are usually have a very large wavelength. Okay. So, we will see that and when we are talking about the tsunami exclusively in one of the lectures in future. Okay. So, let us move ahead. Now, we have different landforms we will come across in the coastal regions like beach, as I told, the most common landform, headlands also, and everything is dependent on the refraction of your waves. Okay. How it approaches the coast. Okay. So, for example, if you are having the coast like this, then how it approaches from this angle, or it is coming straight, or it is coming from this side. So, that will result into the formation of different landforms, plus the lithology of the coastal areas will also play an important role, the rock types. Okay. So, that will also result into the erosion, and in like during the fluvial channel patterns and all that. Okay, what we were talking about, or the fluvial landforms, we discussed about that how the different landforms are forming. Again, it is a matter of the energy conditions and all that. So, now in this case, if you look at, then the waves which are moving towards the coast. Okay. This is having very straight, like it hasn't, it does not have any sort of an obliquity. So, that portion will have a sort of a more erosion and also the deposition over there. Okay. So, if you look at the diagram here, then we have sort of an erosion which will be seen in this area, and then we will have the lateral movement of the waves, and this portion will have the deposition. And such areas which are like you have slightly curved portions, those are been termed as bay areas. Okay. Plus the crest of the waves will be relatively more closer as compared to what you see in the deeper portion of the ocean. Okay. And this movement of the waves, which will also bring the sediments, we call this as a lateral drift. Okay. So, what we have here is, one is your erosional landforms, okay, and which are mostly we will see that they are termed as headlands, and we will have cliffy coast. Okay. And then you have the bay area where you will see the formation of beach. Okay. So, this portion you will see a beach, and here you will have the cliffy coastal banks. Okay. So, these are what we term this as an headlands. Okay. This is from Andaman. So, we have the headlands here. Okay. This is your headland. So, now coastal landforms related to sea, ocean and land contact, because as I told in the previous lecture that this will depend upon the wave action and all that. Okay. So, landforms are basically a result of sea level fluctuation erosion as well as sea level fluctuation. If the sea level goes down, then you will see different landforms. If sea level goes up, you will see different landforms, but most common will be your terraces. Okay. So, sea level fluctuation could be related to your interglacial glacier periods. Okay. So, during interglacial periods, you will have high sea. Right now, we are in interglacial phase, and low sea is during the glacial period. Sea waves erosions or erosion caused by the wave action will result into the formation of the landforms. Okay. So, again we are bringing here the erosion part, okay. And same was during the fluvial landforms also, where we were talking about the terraces. Terraces are erosional, are formed because of the erosional processes. Okay. And also the landforms can form because of tectonic movements. Okay. So, what we will do, we will try to differentiate between the tectonic and non-tectonic landforms, that is the non-tectonic are formed because of the climatic fluctuations. Okay. And that climatic fluctuation is related to your sea level fall and rise. Okay. So, lateral drift, as I have already shown you in the previous slide. So, wave breaks along the shore generate tremendous energy to move sediments along the shore or shoreline in a process called lateral drift. Okay. So, this is how it happens, okay, and it results in the formation of the beach. Okay. So, you have swash and backwash actually. Okay. So, wave getting in and coming back, and that will result into your lateral drift also. Okay. So, this is your lateral drift and beach drift, okay. Lateral as well as the beach drift. Swash and backwash, okay, moves sand and gravel along the beach in a zone of breaking wave. Okay. Further, if you look at, so this is typical of the long shore currents. Okay. So, long shore drift. So, one is the beach drift, another is the long shores. This forms a part of the lateral drift also only. Okay. So, long shore drift, wave action creates long shore current near the beach that carries sediments along the long shore drift, okay, as long shore drift. Further, this drift, okay, if it continues, can result into the formation of a landform here, because the sediments are coming and getting deposited over here, and slowly this may extend, okay, further, and this curved type landform is been termed as spit, and the inner area which we see as sort of a circular part has been termed as bay areas. Okay. So, this is so what we see is the beach formation, and you are having the spit formation, both are because of this process. Okay. Now, another part which is important for us is the tidal range. Okay. So, tidal range usually we measure as, like, we have the mean tide, then you have high tide, and then you have low tide, because this will also result into the formation of your different type of landforms in the area. So, if we look at the Indian side, including the Andaman part and all that, so the wave height at some locations are greater than 4 meter. That is, your tidal range is about almost like 4 meters. Okay. And in some area it is 2 to 4 meters, and then in some portion of the east, we can say most part of the east coast of the mainland India, we have the lesser tidal range, that is less than 2 meters. So, these all points we should keep in mind when we are talking about the runoff process, when we will talk about the tsunamis. Okay. Now, coastal processes and associated landforms. Okay. So, if we see the coastal landforms depends on coastal erosion, transportation of the sediments, deposition. So, the coastal erosion dependent on dimension of the wave, one, configuration, that is shape of your shoreline, strength of the wave that erodes, angle at which it meets the shoreline. Okay. So, as we have seen in the previous slide. Okay. So, in which direction it is moving. Okay. So, what is the angle and what will be the energy conditions. Okay. Depending on that, you will have the formation of the different landforms. Okay. Then further, depending on the above parameters, following landforms can form. Okay. Now, what are these landforms? One is the headlands, sea cliffs, natural bridges, sea stacks and tambolo. Okay. So, these are the few landforms which will be typically most common landforms which will be seen along the coastline, if the coastline is rocky coastline. Okay. So, coastal landforms, let us look at the erosional coastal landforms, then you have sea cliffs, shore platforms, okay, sea notches, sea arc, then you have caves, marine terraces, stacks and wave cut benches. Okay. So, this diagram that shows all different type of landforms which exist. Okay. So, you have shore platform, you have arc, okay, you have stacks, okay, and then you have sea notches. So, sea notches are typically, you will see, if you see over here something like this, okay, shape. We will come to that part also, because for our study this is important, the sea notches and all that. Okay. And marine terraces also, of course. So, these are the examples of stacks and sea cliffs. Okay. So, this is your sea cliff and these are all stacks. Okay. Basically eroded because of the your wave action. Now, Andaman if we take, then we have like the Andaman Sunda Trench, and this is the line of the subduction zone. So, bold line with the triangles, it shows the line of the subduction zone. So, you have Sumatra Andaman subduction zone, and further if you go towards north, then you have this Arakan subduction zone. Now, this area, since we are going to deal mostly with the tsunamis and tsunami related because of the mega thrust earthquakes or tsunami-genic earthquakes, we can say, and the earthquakes which have triggered transoceanic tsunami, that the tsunami got like moved into different oceans, okay, Arabian Sea and even the Indian Ocean and all that. So, it affected the most of the coastal areas. So, that part we will try to look at. And so, here the subduction is between the Indian plate or Indo-Australian plate and Burmese microplate, which we can talk about. And in this diagram, if you carefully look at that, what the pink, not the violet line here, the area, it shows that this whole area got ruptured during 2004, and the length was almost like 1300 kilometers. So, this is a rupture area. Plus, this diagram also shows that there are earthquakes of large magnitude earthquakes, okay, 7.5, 7.9, 7.7 during the historical past. Okay. So, if you start from the north, then we have 1760 2 earthquake, that is what we call the Arakan subduction zone earthquake, 7.5. It also resulted into the tsunami. Okay. Then we have 1679, 1941, 1881, and then you have 1847. So, this shows that this area has remained active in the past, and it has proved in 2004 okay, that it can trigger or host mega subduction zone earthquakes. Okay. On the right hand side diagram, it shows the land level measurements which were been collected after the 2004 earthquake. Okay. And this area which has been shown as the Andaman archipelago, only this portion which is shown by the white box here. Okay. So, this is the portion which has been shown in the right hand side figure. So, what happened was there was a push from this side, okay, and that resulted into the tilting of the island. Okay. So, for example, you have this island here and there was a push because of the subduction. So, it tilted like this, okay. And that what we were able to gather based on the measurements which we did and other teams also did. So, we compiled all the data and prepared this figure, okay, which shows that there was this was a pivotal line along which nothing happened. Okay. It was like 0, no change. Whereas, on the you can say the west bank, okay, and this is the eastern bank, the western side was uplifted. So, this was uplifted and this side subsided. Okay. And that is why we have shown that with the negative, and these are all in meters. Okay. So, there was a tilt like this, where in the northern side of the Andaman archipelago we observed an uplift of the coastal area by almost like 1.1 to 1.3 meters. Okay. And on the eastern portion we were having subsidence maximum up to 1 meter. We will discuss this when we are talking about the tsunamis in Andaman. We will talk about in this in detail. Okay. So, this is an island, this is from Google image we can see. Okay. So, this is in your arc area, okay, and this is a back arc region. Okay. So, nothing was been observed in this region, but yes, in some earthquakes this will get affected. Okay. So, this was like this is the back arc area, and you have the mainland part on the top. Okay. So, as I told that this is the figures which shows that the eastern portion of the Andaman islands were subsided, and the subsidence was much higher, okay, close to the Sumatra region, and that is your Great Nicobar and all that. The subsidence was up to an order of 2 to 3 meters. Okay. Car Nicobar, it was around 1.5 to 2 meters. Now, formation of sea notches, as we talked about, let us look at a few examples from Andaman and then we will move ahead. Okay. So, basically what process it involves is and again as we were discussing that this is because of the erosion, we will see. Okay. So, wave action and wave height will also result into the it will have direct influence on the dimension of the landforms also. So, during high tide the wave keeps coming and eroding this part, and finally, what you will see a sort of an development of this landform. Okay. and that is your sea notches. Okay. So, it will keep collapsing also, but it will keep sometime it remains preserved if the sea level changes. Okay. So, sea notch again, as we were talking about, that we have the tidal range, high tide and low tide, and this portion is your mean tide. Okay. So, the top one will be indicating your the effect of high tide, and the bottom one will be your low tide, and that will also result into the formation of the wave cut platforms. Okay. Now, if you have the either the sea level has gone down, or there was an uplift of the area. Okay. So, on the top figure it shows the formation of sea notch because of the erosion, and if the area gets uplifted, suppose the sea notch was forming here. Okay. And now this area goes up. Okay. So, sea notch will start forming over somewhere over here. Okay. So, these are what we see, that there are two sea notches. This is the present day newer sea notch, and this one is the older sea notch along with the sea cliff. Okay. So, if you are able to see multiple sea notches, that also helps you in understanding that either the sea level has gone down. Okay. So, that is fall in sea level, or the sea level did not, it remain like stable, but there are the landforms which are indicating that there was some change in the base level. Okay. So, or we can say the land level. So, then land level change, that sort of land level change can be related to tectonics. And in Andaman we see this example of multiple sea notches. So, this is a Neil Island which exists. I will just show you the location of this. Okay. So, this is a Neil Island, okay, which is on the back arc area. Now, in this portion, what we were able to pick up was multiple sea notches, but we will just look at the example here and then move ahead. Okay. And then, so this is one very good example of sea notch at Neil Island. We have arc also. Okay. So, this is an you can say sea gate or arc. Okay. And then these are the notches here. Okay. So, we have multiple notches which we were able to pick up. Okay. So, you have a small notch over here like this, then it goes like this over here, then another one is over here, then another one is over here. Okay. So, you have multiple sea notches. Now, as we have learned that these notches are because of the erosion by tidal waves, and this also indicate the past sea level. So, that means that during the formation of this notch, the sea level was probably here, which is bit unusual because it is quite high. This area is like almost like more than 10 to 15 meters. Okay. So, if you see close up of this portion, then you will be able to make out clearly that because of the wave action, this is a smaller waves present day, but this is a larger one here. Okay. So, this was the mean tide level, this we can say high tide, and this is your low tide. So, such landforms are very important when we are talking about the tectonics and climatic effect. Okay. So, we will continue in the next lecture, okay, from this point. Till then, thank you so much. Namaskar.